Hello everyone. So today we are going to talk about connectivity in graphs. In a graph G, a path of length k is a sequence of k plus 1 distinct vertices so that there is an edge between each consecutive pair of vertices. And a cycle of length k is a path of length k except its first and last vertices are the same. That means you have k distinct vertices in a cycle. Let's take an example like this one. So this is a graph G. What would be a path of length 3? So this would be a path of length 3. A, D, E, F is a path of length 3. There are 4 vertices. And 3 edges, so length 3. Can we find a cycle? Sure, this will be a cycle. So A, D, C, B is a cycle of length 4. There are 4 vertices, 4 edges, so the length of the cycle is 4. Remember, whether it's a path or a cycle, the length depends on how many edges are there in that path or that cycle. Next, a graph is connected if there is a path between every pair of vertices in the graph. So that's a graph, we call it connected. For example, this graph. This is one graph, not 2 separate graphs. We are considering them as one graph. This graph is not connected right now. There is no path between A and D, or A and C, or C and E. So these are 2 different components. We call them components. So this is a graph, one graph, and it is not connected. There are 2 disjoint connected components. Now if we add this edge, now there is a path between every pair of vertices, between A and D, between C and D, between C and E. So now it is connected. The next definition is connectedness in directed graph. So a directed graph is strongly connected if for every pair of vertices there is a path from A to B and B to A. A weakly connected directed graph is if the underlying simple graph is connected. So let's see. This is a graph, one directed graph. Is it strongly connected? So let's say 2 pair of vertices A and B. There is a path from A to B and B to A. Between A and C, there is a path from A to C and C to A. So it is strongly connected. So this is a directed graph. It is strongly connected. Now let's see this graph. This is a directed graph. Is it strongly connected? Do we have a path? Let's take a pair of vertices A and B. We have a path from A to B. Do we have a path from B to A? We do not have a path from B to A, so it is not strongly connected. It is actually weakly connected. How do we know it's weakly connected? If the underlying simple graph, what is the underlying simple graph? If you forget the arrows, then you get the underlying simple graph, undirected graph. And that underlying undirected simple graph, that is connected. That's why it is weakly connected.